Dear students, Namaste, good morning to you all, and also welcome to another session of our mathematics class. In the previous session, we have discussed question number 1 to 8 from the miscellaneous exercise. And in today's session, we shall discuss the remaining problems from the miscellaneous exercise. Let's move on to the topic. Next, we shall discuss question number 9. The question is, find the position vector of a point R which divides the line joining 2 points P and Q, whose position vectors are 2a plus b and a minus 3b externally in the ratio 1:2. Also show that P is the midpoint of the line segment RQ. Here in this question, two parts are there. In the first part, we have to find out the position vector of R. For that purpose, two conditions are given. First condition is P and Q position vectors are given, that is 2a plus b and a minus 3b, and the second condition is external division ratio is given 1:2. By using these two conditions, we have to find out the position vector of R, that is OR we have to find out. And in the second part, we have to show that P is the midpoint of RQ. So let's write the given conditions. Position vector of P, that is OP, is 2a plus b, and position vector of Q, that is OQ, is equal to a minus 3b. And there is an external division formula. OR is equal to mb minus na divided by m minus n. M into the second vector minus n into the first vector divided by m minus n. Here OR is equal to m. M is 1. 1 into the second vector a minus 3b. 1 into a minus 3b minus 2 into the first vector, that is 2a plus b, divided by m minus n, that is 1 minus 2. Let's go for calculation. A minus 3b into 1 is a minus 3b minus 2 into a vector, that is 2 into 2 is 4. 4 into vector a minus, here minus 2 into b, that is minus 2 into vector b, divided by minus 1. Here a and minus 4a, that is we will get as minus 3a, and minus 3b is here, minus 2b is here, minus 3 minus 2 is minus 5b, divided by minus 1. Here there is a minus sign common in both numerator and denominator. Let's cancel it and we will get the final answer as 3a plus 5b. 3 into vector a plus 5 into vector b. Here first part is over, and in the next portion we have to show that P is the midpoint of the line segment RQ. So midpoint, we know the formula, that is vector a plus vector b divided by 2. The sum of the vector divided by 2. The position vector of the midpoint RQ. So here midpoint of RQ we have to calculate, and we have to show that it is equal to P, position vector of P. So RQ, that is OQ plus OR divided by 2. Position vector of Q plus position vector of R divided by 2. Even if you change the order, it is not a problem. And position vector of Q, we know that it is a minus 3b. It is substituted, plus position vector of R we have calculated 3a plus 5b divided by 2. That is equal to, after doing calculation, we will get it as 2a plus b. 2 into vector a plus b. Here a and 3a, that is 4 into a vector, and here minus 3b plus 5b, that is plus 2 into vector b will come. Then 2 is common for both numerator and denominator. After cancelling 2, we will get as 2 into vector a plus vector b. And here when you check it with the position vector of P, that is also same, 2 into vector a plus vector b. So that is equal to OP. Therefore P is the midpoint of line segment RQ. That is what we have to show. Next we shall discuss question number 10. The question is, the two adjacent sides of a parallelogram are 2 cap minus 4 cap plus 5 cap and cap minus 2 cap minus 3 cap. We have to find the unit vector parallel to its diagonal and also find the area. Here we have to find out the unit vector parallel to the diagonal. If you take this vector as A and this one as B, then the diagonal of the parallelogram can be calculated by using the formula a plus b, and area of the parallelogram can be calculated by using the formula modulus of a cross b. First of all, we have to go for a cross b, then we have to find out its modulus value. So let's take this one as A and B. Then the diagonal of the parallelogram is vector A plus vector B. Let's add it. Just add the components here, 2 and 1 scalar components, that is 2 and 1 with I cap. So 2 plus 1 into I cap, plus here minus 4 and minus 2 with j. So minus 4 minus 2 into j cap, plus 5 and minus 3. So 5 minus 3 into k cap. When you do the calculation, 2 plus 1 is 3 into I cap, minus 4 minus 2, that is minus 6 into j cap, 5 minus 3 is 2 into k cap. That is unit vector parallel to the diagonal. We have to convert this one into unit vector form. That is very simple. A plus b is there. If you divide a plus b with the modulus value, then we'll get the unit vector. So a plus b divided by modulus of a plus b is equal to a plus b, we have 3i cap minus 6j cap plus 2k cap, it is written, divided by root of modulus of a plus b, that is root of x square plus y square plus z square, that is root of 3 square plus minus 6 the whole square plus 2 square. That is equal to 3i minus 6j cap plus 2k cap divided by 3 square is 9, minus 6 square is 36, plus 2 square is 4. That is 3i cap minus 6j cap plus 2k cap divided by 36 plus 4 is 40, 40 plus 9 is 49, square root of 49 is 7. Let's split it this one, that is 3 by 7 into I cap minus 6 by 7 into j cap plus 2 by 7 into k cap. This is the unit vector parallel to the diagonal of the given parallelogram. Next we have to go for A cross B, because area of parallelogram is modulus of A cross B. Determinant form ijk first row and the A vector components, that is second row. A vector component is 2, minus 4 and 5. It's written here. And B vector component will come as third row. B vector components are 1, minus 2 and minus 3. That is written here. So for the calculation, I cap into row and column is gone. Minus 4 minus 3, that is plus 12. Minus into minus plus, that is plus 10. So 12 plus 10 minus j cap into that row and column is gone. 2 into minus 3, that is minus 6. Minus 5 into 1, that is minus 5. Plus k cap into that row and column is gone. Then 2 into minus 2, that is minus 4. Again minus into minus plus, 1 into 4 is 4. So minus 4 plus 4. That is equal to 12 plus 10, that is 22 into I cap. Minus 6 minus 5, that is minus 11. Minus into minus plus 11 into j cap. Plus 11 into j cap is written here. Then this minus 4 plus 4 will become 0, and multiplying with the k cap, the entire term will be 0. Then we have to go for finding out modulus of A cross B, because area of parallelogram formula is modulus of A plus B. That is equal to root of 22 square plus 11 square, x square plus y square format. That is root of 22 square plus 11 square. That is equal to, we can split this 22 as 2 into 11 and plus 11 square. You can do it in any format. This one something which I am doing. Which one is convenient method, that way you can follow. It's not a problem. Then here 11 square, if you take outside, will come as 11, and inside the root there is 2 square, that is 4, and here 11 square is coming out, means it is 1 balance, that is equal to 11 root 5. So the area of the parallelogram is 11 root 5 square units. Move on to question number 11. The question is, show that the direction cosines of a vector equally inclined to the axis OX, OY and OZ are 1 by root 3, 1 by root 3, 1 by root 3. Here, given condition is equally inclined. A vector which is equally inclined to the axis OX, OY and OZ means equally inclined in the sense the angle in which the particular vector makes with the X, Y and Z axis are same. Then we have to show that the direction cosines are 1 by root 3, 1 by root 3 and 1 by root 3. Let a vector be equally inclined to OX, OY and OZ at an angle alpha. As I said, equally inclined in the sense the angle in which that particular vector makes with the X, Y and Z axis are same. Here we are taking it as alpha. So the DCs of the vector are cos alpha and cos alpha. Since all three angles are alpha, means same, we can take the direction cosines are cos alpha and cos alpha only. cos square alpha plus cos square alpha plus cos square alpha is equal to 1. We have learned the formula L square plus M square plus N square is equal to 1. So L, M and N are same here. That's why here cos square alpha plus cos square alpha plus cos square alpha is equal to 1. So that is 3 cos square alpha is equal to 1. That is cos alpha is equal to 1 by root 3. Cos square alpha, if you want to calculate from cos square alpha means we have to take the square root. Square root, if you take square root of 1 divided by square root of 3. Square root of 1 is 1 itself. So 1 by root 3 is cos alpha value. So the direction cosines of the vector are 1 by root 3, 1 by root 3 and 1 by root 3. Here cos alpha is 1 by 3, that is L. L is 1 by root 3. Here L, M and N are same. Direction cosines are represented by L, M and N. Here L square, M square, N square is equal to 1. By using that formula we calculated the value of cos alpha. So cos alpha means direction cosine. Usually we denote with the symbol L. L is 1 by root 3, M and N also 1 by root 3. So the direction cosines of the vector are 1 by root 3, 1 by root 3 and 1 by root 3. Next we shall discuss question number 12. Let vector A is equal to I cap plus 4j cap plus 2k cap and vector B is equal to 3i cap minus 2j cap plus 7k cap and vector C is equal to 2i cap minus j cap plus 4k cap. Find a vector D which is perpendicular to both A and B and C dot D is equal to 15. Here three vectors A, B and C are given to you. You have to find out another vector D. The property of that D is perpendicular to both A and B. And one more condition, C dot D is equal to 15. Here let's write the given vectors. A is I cap plus 4j cap plus 2k cap. B is 3i cap minus 2j cap plus 7k cap and C is equal to 2i cap minus j cap plus 4k cap. Let's take the given vector, required vector, that is D is equal to xi plus yj plus zk. Xi cap plus yj cap plus zk cap. And by using given condition we can say that D is perpendicular to A. D is perpendicular to A means their dot product is 0. D dot A is equal to 0. So D is xi plus yj plus zk and A is I plus 4j plus 2k. Dot product in the sense multiplying the components, that is 1 into x, that is 1x, 4 into y, that is 4y, 2 into z, that is 2z is equal to 0. Let's take it as equation number 1. Next is D is perpendicular to B. That means D dot B is equal to 0. D is here, B is here. 3 into x, 3x, y into minus 2, minus 2y, 7 into z, that is 7z is equal to 0. Let's take it as equation number 2. And another one is C dot D is equal to 15. Here C dot D 15 in the sense D is here, C is here. 2 into x, 2x, minus 1 into y, that is minus y, 4 into z, that is 4z. 2x minus y plus 4z is equal to 15. That we have formed an equation. Label it as equation number 3. We have 3 equations and 3 variables x, y and z. So we have to find out x, y and z. Equation number 1 into 3. I am first considering equation 1 and 2 and by equating coefficient means here coefficient of x is 3. Here is 1. If I multiply 3 here, these coefficients will be equal in equation number 1 and 2, x coefficients. So if I multiply with 3, 3x plus 12y plus 6z is equal to 0. And second equation same, 3x minus 2y plus 7z is equal to 0. If I subtract these two equations, x will be eliminated and I will get as 12 minus minus 2, that is 12 plus 2 is 14y, 6 minus 7z, that is minus z is equal to 0. That we can take it as equation number 4. Next equation number 2 and 3 I am taking, and here equation number 2 into 2 implies we will get it as 6x minus 4y, 7 into 2 14 z is equal to 0. And equation number 3 into 3, when you multiply it, 3 into 2 6x minus 3 into y, that is 3y, then 4z into 3, that is 12z is equal to 15 into 3, that is 45. Here also we made x coefficients equal. Here coefficient of x is 3, that I multiplied with this one. Here coefficient of x is 2, that I multiplied with equation number 2. So just subtract it. We will get as minus 4 minus minus 3, that is minus 4 plus 3 minus y minus 1y. 14 minus 12, that is 14 minus 12 is 2z. 0 minus 45, that is minus 45, that we have to take it as equation number 5. When you check equation number 4 and 5, there are only two coefficients, y and z. So equation number 4 into 2, just multiply equation number 4 with 2, that will come as 28y minus 2z is equal to 0. Then equation number 5 is same, just same. Now here when you check, is coefficient of z are same. Here it is minus 1 was there, here it is 2 was there, so I multiplied 2 here, so the coefficient of z in 4 and 5 will be same. So equation number 5 I am taking same as it is, that is minus y plus 2z is equal to minus 45. Then we can go for calculation. Minus 2 and plus 2, when you add these two, this becomes 0. What we have to do, just add it. 28 minus y, 28 minus y is 27y. 0 minus 45, that is minus 45, that is y is equal to minus 45 by 27. When you cancel here 9, we will get it as minus 5 by 3. Y value we have got minus 5 by 3. Then equation number 4, when you take equation number 4 and substitute the value of y, we will get as 4 is here, 14 into minus 5 by 3 minus z is equal to 0. That is z is equal to 14 into minus 5, that is minus 70, minus 70 divided by 3. So minus 70 by 3, when it goes to the right side, it becomes plus 70 by 3. But here there is a minus with a z. So that minus will be coming to the right side, that is minus 70 by 3 is the answer for z. Once again, here 14 into minus 5 is minus 70. Minus 70 by 3. This minus 70 by 3, when it goes to the right side, it becomes plus 70 by 3. But here there is a minus z. So when you write the answer, z is equal to minus 70 by 3 will come. Let's substitute the values of y and z in equation number 1. X plus 4y plus 2z is equal to 0 was equation number 1. So equation number 1 implies x plus 4 into y value we have got minus 5 by 3 plus 2 into z value we have got as minus 70 divided by 3 equal to 0. That is x plus 5 into 4 is 20, there is a minus sign, so minus 20 by 3. Then 7 into 2 40, that is 140. 70 into 2 is 140, there is a minus sign, so minus 140 by 3 equal to 0. Let's take 3 as common LCM. So x minus 3, if you take common LCM, minus 20 minus 140, that is minus 160 by 3 equal to 0. X is equal to this minus 160 by 3 will come to the right side as plus 160 by 3. Now we have got all the values. X value is 160 by 3, y value we have got as minus 5 by 3, and z value is minus 70 by 3. Let's substitute this all in our required vector, that is d is equal to xi plus yj plus zk. That was our assumption. Let's substitute it. D is equal to x value is 160 by 3 into I cap minus y value was minus 5 by 3 into j cap. Then z value is minus z by 3 into k cap. That is 1 by 3 if you take common outside, 160 I cap minus 5 j cap minus 70 k cap. This is the required equation of the vector. Next we shall discuss question number 13. The scalar product of the vector I cap plus j cap plus k cap with a unit vector along the sum of the vectors 2 I cap plus 4 j cap minus 5 k cap and lambda I cap plus 2 j cap plus 3 k cap is equal to 1. Find the value of lambda. Here the question we have to go through in detail. The scalar product in the sense dot product of the vector, this one, and the unit vector along the sum of the vectors, these two. So once again, the scalar product means the dot product of this vector and the unit vector. Unit vector, we know that a vector when it is dividing with its modulus, then we will get the unit vector. Unit vector of the sum of these two vectors. So first of all, we have to find out the sum of the vectors, these two. 2 I cap plus 4 j cap minus 5 k cap plus lambda I cap plus 2 j cap plus 3 k cap. Just pair it the components, that is 2 and lambda, 2 plus lambda into I cap, 4 and 2, that is 6, 6 into j cap, then minus 5 plus 3, that is minus 2 into k cap. That is the sum of the vector. Not only simply the sum, it is a unit vector along the sum of the vectors. So unit vector along the sum, that means 2 plus lambda I plus 6 j cap minus 2 k cap. That is the sum. So we have to find out the unit vector along this one. Unit vector calculation we know, just the vector divided by its modulus. So vector is 2 plus lambda into I plus 6j minus 2k cap divided by its modulus value is x square plus y square plus z square, that is root of 2 plus lambda the whole square plus 6 square minus 2 the whole square. That is numerator remains the same, denominator we can expand it, that is root of 2 square is 4, then 2ab, a plus b the whole square expansion, 2ab in the sense 2 into lambda, that is 4 lambda plus lambda square, 6 square is 36 minus 2 square is 4. That is numerator is same, denominator is lambda square is the first quantity, then 4 lambda, there is no other lambda here, so 4 lambda remains the same. There are constants, 36 plus 4 40 plus 4 is 44, so it is simplified. Then according to the given condition, the dot product or the scalar product of the vector this one and the unit vector, so this one means I cap plus j cap plus k cap, that is written dot the unit vector is this one, 2 plus lambda into I cap plus 6 j cap minus 2 k cap divided by root of lambda square plus 4 lambda plus 44 equal to 1, that is equal to 1 we have written. Go for calculation. Dot product in the sense just multiply the components, here 1, here 2 plus lambda, so 1 into 2 plus lambda is 2 plus lambda, here there is 1 and with j cap here is 6, so 1 into 6 is 6, here with k cap is 1 and here with minus 2, so 1 into minus 2 divided by this modulus, we can keep it as it is, equal to 1, that is 2 plus lambda plus 6 minus 2, so 6 minus 2 is 4, 4 plus 2 again, that is 6, and here plus lambda, or simply we can say 2 minus 2 cancelled and we will be having only lambda plus 6 on the right side. This one cross multiply it, root of lambda square plus 4 lambda plus 44 into 1 is same, is equal to lambda plus 6. Just square it to remove the square root, lambda square plus 4 lambda plus 44 is equal to lambda plus 6 the whole square. That is left side is same, right side we can expand by using a plus b the whole square expansion, lambda square plus 6 into 2, that is 12 lambda, 2ab format, that is 6 into 2, 12 into lambda, that is 12 lambda plus 6 square, that is equal to 36. That is here lambda square cancelled, there is a 12 lambda is there on the right side, bigger quantity is on right side, so we can bring all terms to the right, so 12 lambda, this plus 4 lambda goes to the right side, it becomes minus 4 lambda, then 44, that is the bigger quantity in constants, that is on the left side, this plus 36 bring to the left, that is minus 36, 12 minus 4 lambda is 8 lambda, 44 minus 36 is 8, that is lambda is equal to 8 by 8, that is 1, so the value of lambda is. On to question number 14, the question is, if vector A, vector B, vector C are mutually perpendicular vectors of equal magnitudes, show that the vector A plus B plus C is equally inclined to vector A, vector B and vector C. Here the given condition is vector A, vector B and vector C are mutually perpendicular vectors of equal magnitudes. In the sense they are mutually perpendicular as well as their magnitudes are same. And we have to show that their sum, vector A plus vector B plus vector C, is equally inclined to vector A, vector B and vector C. Equally inclined in the sense the angle must be same. Here the given condition is vector A, vector B and vector C are mutually perpendicular vectors of equal magnitudes. In this one line itself there are two conditions. They are mutually perpendicular and their magnitudes are same. Mutually perpendicular in the sense their A dot B and B dot C and C dot A equal to 0. Their dot products is 0. Then equal magnitudes in the sense modulus of A equal to modulus of B is equal to modulus of C. Let vector A plus vector B plus vector C be inclined to A, B and C vectors at angles theta 1, theta 2 and theta 3 respectively. So when you add A, B and C, you will get a single vector. So vector A plus vector B plus vector C. That particular vector is inclined with A, B and C at angles theta 1, theta 2 and theta 3 respectively. That is what our assumption. So angle between the vectors we have already learned. Cos theta is equal to A dot B divided by modulus of A into modulus of B. Means dot product of two vectors divided by their modulus product. So here the two vectors are A plus B plus C and first vector is A. So A plus B plus C dot A divided by modulus of A plus B plus C into modulus of A. That is, when you remove it, when you are finding out the dot product, A dot A plus B dot A plus C dot A divided by denominator is same. That is equal to A dot A we have already learned, that is modulus of A square, and B dot A and C dot A, here it is, they are 0. So we will get in the numerator only A dot A, that A dot A becomes modulus of A square divided by modulus of A plus B plus C into modulus of A. So here there is a modulus of A and here there is modulus of A square. When you cancel it, modulus of A by modulus of A plus B plus C will come. Next, cos theta 2. Theta 2 means A plus B plus C and vector B, second vector. So A plus B plus C dot B divided by modulus of A plus B plus C into modulus of B. As before, just to take the dot product, A dot B, then B dot B, then C dot B divided by the denominator is same. Here A dot B and C dot B become 0 as per the given condition. So B dot B will come as modulus of B square by denominator is same. Here in the denominator there is a modulus of B and in numerator there is a modulus of B square. When you cancel it, you will get as modulus of B by modulus of A plus B plus C. Next is cos theta 3. Cos theta 3 in the sense A plus B plus C with the third vector C. That is A plus B plus C dot C by modulus of A plus B plus C into modulus of C. Taking the dot product, A dot C, B dot C plus C dot C divided by denominator is same. Here like before, A dot C and B dot C will become 0 because they are mutually perpendicular vectors. We will get C dot C. C dot C is modulus of C square divided by denominator is same. And in the numerator there is modulus of C square and the denominator there is modulus of C. One can be cancelled. We will get modulus of C divided by modulus of A plus B plus C. But it is given to us modulus of A, modulus of B and modulus of C are same. Means in cos theta 1, cos theta 2 and cos theta 3, when you check the numerators, modulus of A, modulus of B, modulus of C. Denominators are already same. But the numerators, modulus of A, modulus of B and modulus of C. But it is given both these, all these three, modulus of A, modulus of B and modulus of C are same. They are equal magnitudes. Means their numerators also same. Already the denominators are same. And by using the given condition, we can say that their numerator is also same. That means since modulus of A, modulus of B and modulus of C are same, cos theta 1 equal to cos theta 2 equal to cos theta 3. As I mentioned before, cos theta 1 denominators of this cos theta 1 and cos theta 2 and cos theta 3 are same already. But the numerator, when you check by using that given condition, that is vector A, modulus of vector A equal to modulus of vector B is equal to modulus of vector C. By using this condition, we can make these numerators also equal. So in cos theta 1, cos theta 2 and cos theta 3, numerator and denominators are equal. That means the fraction itself equal. So we can say that cos theta 1 equal to cos theta 2 equal to cos theta 3. So theta 1 is equal to theta 2 is equal to theta 3. Move on to question number 15. The question is, prove that vector A plus vector B dot vector A plus vector B is equal to modulus of A square plus modulus of vector B square if and only if vector A and vector B are perpendicular, given vector A not equal to 0 vector and vector B is not equal to 0 vector. So there is a statement, vector A plus vector B dot vector A plus vector B is equal to modulus of A square plus modulus of vector B square. If and only if A and B are perpendicular. So let's take this statement first and we have to come to this conclusion. A and B are perpendicular. So when you take the given statement, vector A plus vector B dot vector A plus vector B is equal to modulus of vector A square plus modulus of vector B square. Let's take the dot product on the left side. A dot A plus A dot B plus B dot A plus B dot B is equal to right side is same. A dot A we know that is modulus of A square. A dot B and B dot A are same because they are commutative. So A dot B we can write, B dot A we can write as A dot B. So when you add these two, we will get as 2A dot B. Then this B dot B is modulus of B square. So that is modulus of A square. These two together 2A dot B plus B dot B is modulus of B square equal to right side is same. So left side modulus of A square and plus modulus of B square. Right side modulus of A square plus modulus of B square. Both will be cancelled and we will get 2AB, 2 into A dot B is equal to 0. That is A dot B is equal to 0. This is a statement we have got. A dot B 0 in the sense we can come to the conclusion that A and B are perpendicular. So A and B are perpendicular. Next we shall discuss question number 16. The question is, if theta is the angle between two vectors, vector A and vector B, then vector B greater than or equal to 0 only when four conditions are given to you: 0 less than theta less than pi by 2, 0 less than or equal to theta less than or equal to pi by 2, 0 less than theta less than pi, and 0 less than or equal to theta less than or equal to pi. Let's take the given condition A dot B greater than or equal to 0. So A dot B greater than or equal to 0 in the sense, by using the formula we can write modulus of A into modulus of B into cos theta greater than or equal to 0. We know that modulus of A and modulus of B already greater than or equal to 0 means cos theta greater than or equal to 0. Reason, modulus of A and modulus of B is greater than or equal to 0. Cos theta greater than or equal to 0 in the sense theta must be between 0 and pi by 2. 0 less than or equal to theta less than or equal to pi by 2. Then only cos theta becomes greater than or equal to 0. So here the correct option is option B. Question number 17. The question is, let vector A and vector B be two unit vectors and theta is the angle between them. Then vector A plus vector B is a unit vector if first option theta is equal to pi by 4, second option theta equal to pi by 3, third one theta equal to pi by 2, and fourth one theta equal to 2 pi by 3. So this question you will try it as homework. Move on to question number 18. The question is, the value of I cap dot j cap cross k cap plus j cap dot I cap cross k cap plus k cap dot I cap cross j cap is 0, -1, 1 or 3. We have to choose the correct answer from these four options. Let's find out the value. The given statement we have written as it is equal to I cap dot, we have already learned j cap cross k cap. J cap cross k cap is I cap, and we have drawn a circle and we have marked ijk and we have learned this formula. So if you don't know, better to revise it. Then second time if you take j cap dot, here I cap cross k cap, not in order, so there is a minus sign, so minus j cap plus k cap dot I cap cross j cap, so ijk, I cap cross j cap, it is in order, I after that j after that k, so I and j are in order, so it will come as k cap. There is no negative sign here. Negative sign is coming because the order is reversed, I cap cross k cap, that's why. That is equal to I dot I, that is 1, then here this minus will be coming, then j dot j, that is also 1, k dot k, that is also 1. So 1 minus 1 0 plus 1 is 1. So the correct answer is 1. Last question, that is question number 19. If theta is the angle between any two vectors, vector A and vector B, then modulus of A dot B is equal to modulus of A cross B when theta is equal to four options: 0, pi by 4, pi by 2 and pi. Here modulus of vector A dot vector B is equal to modulus of vector A cross vector B. That is the given condition. Let's substitute the formulas. Modulus of A dot B, that is modulus of A into modulus of B into cos theta, is equal to A cross B formula, modulus of A modulus of B into sin theta. So here this one, modulus of A B are there in both sides, gone. That is cos theta equal to sin theta. When you take this cos theta this side, that is sin theta by cos theta. Cos theta we are taking to right side, so that becomes divided by cos theta. So sin theta by cos theta is tan theta. On the left side it is 1, so tan theta is equal to 1. Then theta is equal to pi by 4. For what value of theta? Tan theta is 1 in the sense theta is 45, so theta equal to pi by 4. So the correct option is option B. Dear students, today we have completed the miscellaneous exercise and also completed the chapter Vector Algebra. Please go through the entire chapter, and while practicing, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.